Hey there, how you doing? I'm glad you were able to come again. Yeah, have a seat, have a seat. I was so excited to talk about that other story you were telling me about your neighbors, Joe and Gina. So nice that we were able to help them. So the story you told me was Gina comes over and says, hey, listen, I need some help. I know you're a CPA, I know you're pretty good with numbers. And you're like, yeah, what can I do for you? Well, my husband Joe. My husband Joe, as you know, he's a driver for this company across town. And there's this policy at the company where if you make an improvement, a significant improvement, you can get an employee reward up to $500. And so Joe makes this suggestion. They got this driving route. He says, I got a better driving route. Let's do my driving route. And they look at it and they say, no, we're not going to pay you. But Joe really thinks it's an improvement and he should get paid. So he's in a union. He's able to appeal the process. He does an appeal. And he'd like you to take a look at the numbers, and if you think it's valid, make the appeal, and maybe even go to the mediator with him. So you say, sure, let me take a look at the numbers. So Joe sends the numbers over to you, and you look at them, and you're like, okay, well, let me understand what you're doing here. Joe says, well, what they normally do is it takes 90 minutes to drive this route round trip. I think they're taking the wrong roads and the wrong turns. I got a different route, it takes 85 minutes. And so you look at it and you say, okay, well, I see that the company's tested it 20 times. They've tested this route 20 times. And I see from the data, it has a standard deviation of 6 minutes. So I have looked at the data and I think you got a case. Okay, so you go to the hearing. Now, meanwhile, this hearing is off on this, kind of a strip mall. It's a small office, kind of drafty, kind of airy. The judge there, it looks like he's an older fella. He's late 60s. He used to be a judge, actually, this mediator. And he's got that authoritative voice. And you guys said, but he sits down. And the attorney for the representative for the company, he's kind of this slender guy with a thin mustache and a fraying brown suit. He doesn't look too impressive himself. But anyway, that's not the point. So it goes to the mediation. Mediator says, I've read the data. Tell me a little bit about what you're saying here. So this guy here from the company says, listen, you have to be significant. He's knocked a few minutes off, that's all. And we don't think that's significant. It's our choice. We're the company. We say this is nothing here. And they turn to Joe, and Joe says, hey, talk to my CPA. So you tell them, well, there's no criteria. Significant can be construed. You can't just let the company decide what's significant. Let's look at what is statistically significant based on the data. Here's some charts, here's some graphs, here's some information. This is why I think Joe should get the money. So judge, the mediator, the ex-judge takes it back and he says, okay, let my experts look at your numbers and I'll render a decision. So a couple of days later, the decision comes down, pay the man. It's statistically significant. Joe gets his money. So naturally, Joe's ecstatic and very pleased. And so is Gina, and they're all happy. And so I said, well, how did you do that? What exactly did you show this guy? I mean, it just sounds like a few minutes. So, here's the data. And I said, well, wait a minute. Slow down there. What are you showing me? Well, the first piece there is the value, the theoretical value. That's the control value is 90. This new data is 85 minutes to make the case, to make the drive, to make the round trip drive. It has a standard deviation of 6 minutes, and the sample size was 20. They tested this 20 times. Well, then you have to determine if it's statistically significant. Wait. Back up. Hold on a bit. You have to slow that down for me. Just a minute. How do we determine if those few pieces of data is statistically significant? Well, we have to compare the test statistic derived from the data to the critical value. And since the sample size is less than 30, we use a t-statistic as that test statistic. You look it up in a formula, you Google it, and you get this formula here, where t is equal to the mean minus the theoretical value divided by the standard deviation divided by the square root of n, which is the sample size. Okay, I think I can get that. All right, let's just plug in the values, see what you get. Well, that's 85, that's Joe's number, minus 90, that's what the company's number was, divided by 6, there's your standard deviation, divided by the square root of 20, which was the sample size. You can do that on a calculator or Excel. That's a pretty easy number to calculate. And t equals minus 3.72. Okay, explain what we do next. Okay, well, as you said, we have the first value, we need the critical value, t, to compare. And we're going to compare our test statistic to a critical value at 0.05 or 5%. So our critical value is a t-value based on the degrees of freedom, where the degrees of freedom is equal to n to minus 1. Well, n was the sample size of 20, minus 1, so our degrees of freedom is 19. And so we can just put that in. There's two ways to do this. We can do it from a table, or we can do it from Excel. The Excel formula is equals t dot inv, open parentheses, put in your alpha value, comma, put in your degrees of freedom, close the parentheses. Or in this case, t dot inv, open parentheses, 0.05, your alpha, comma, 19, that's our degrees of freedom, we said before, 20 minus 1, close parentheses, you hit enter. Boom! Excel kicks back minus 1.729. But if you're not comfortable doing that, you can go to a table. You, once again, just go to Google and you put in a student's t-table, and up comes this graph, or this chart here, I should say. Now, on the top, you go across the top where it says one-tail test. You slide over till you see where it says 0.05 on the top. You take that, you look down that column to the degrees of freedom is 19, and you see it says 1.729. Now, since we're on the left side of the table, or left side of the mean, it'll be a minus, so minus 1.729, and that's the same value Excel came up with. So I get a little confused here. I said, so help me understand. You got these two numbers. One's bigger than the other. One's smaller. You got two negative numbers. Well, how do we approach this again? And you told me, well, just look at the graph. So in the graph, you have that mean in the middle, the t. That's that would be the value of 90. So anything to the right of that line there, anything to the right says, yeah, it's within 90. Anything to the left there, which is a very small area, says that at that critical juncture, you made a significant contribution. It's a significant difference. Well, on the graph there, that line there is minus 1.729. So anything to the left, you'd reject the null hypothesis. Well, our test statistic is minus 3.72. We reject the null hypothesis, and therefore the driving root is statistically significant. Well, what happens? Joe got the bonus, obviously. He's very pleased. Gene is very pleased. They invite you over for dinner. Have a nice Italian dinner. They got some lasagna and some garlic bread, some salad. For dessert, they got some nice cannoli, and they're all very happy. And I bet you're happy too. What you told me was, it also feels good to use your skills and ability to help someone else. And you know what? That's what makes you one ace accountant. Let's give you a round of applause. I'll see you later, all right? Bye-bye.